Welcome. Today, part 4 of the chapter Binomial Theorem for preparation of JEE Main and Advanced and for different state level joint entrance examination. First problem for today is problem number 14 of that chapter, and the problem is if coefficient of rth and r plus 1th term of 3 plus 7x to the power 29 are equal, then r is 14, 21, 22 and 23. In this case, the problem is also very simple. One binomial is this: given that coefficient of its rth and r plus 1th terms are same, coefficients are same, then value of r is optional this. So coefficient of rth term is equal to 29 c r minus 1 into 3 to the power 29 minus that is 3 to the power 30 minus r into 7 to the power, not 7x, because we want only coefficient, 7 to the power r minus 1. And coefficient of r plus 1th term is equal to 29 cr 3 to the power 29 minus r into 7 to the power r. And after obtaining this, given that the coefficients are equal, therefore we must have 29 c r minus 1, 3 to the power 30 minus r into 7 to the power r minus 1 is equal to 29 cr 3 to the power 29 minus r into 7 to the power r. Few terms will be cancelled. Between this and that, only 3 will be there, and between this and that, 7 will be there. So 29 c r minus 1 into 3 is equal to 29 cr into 7. So we have this is equal to that. That means 29 cr by this by that 29 c r minus 1 is equal to this by that, it will be equal to 3 by 7. Simplifying, factorial 29 by factorial r into factorial of this minus that 29 minus r by this factorial 29 into factorial of r minus 1 into factorial of this minus that is 30 minus r is equal to 3 by 7. This cancels. Between this and that, r will be there. Between this and that, so 30 minus r by r is equal to 3 by 7, so that by cross multiplication minus 7r is equal to 3r. That is 10r. 210 is equal to 10r. Hence r is equal to 21. So this option is correct. Next, problem number 15. Problem number 15. In 1 plus x to the power m into 1 minus x to the power n, in this expansion, the coefficient of x and x square are 3 and minus 6. Then m is options 8, 9, 12 and 15. In that expansion, coefficient of x is 3 and coefficient of x square is equal to minus 6. Then to find m, value of m. Now this expansion is equal to 1 plus mc1 into x means mx plus mc2, it is m minus 1 by 2 mc2 into x square. After that, they have no contribution for coefficient of x and coefficient of x square. And the second one is 1 minus nx plus n minus 1 by 2 into x square. This. Now, coefficient of is equal to 1. Now I collect coefficient of x. So it is equal to mx into 1 is m, and this into that is another coefficient of x, m minus n into x. There is no other coefficient of x. Now x square, coefficient of x square, first thing 1 into that is n into n minus 1 by 2 into x square. This with that minus mn, this into that is again x square. So plus m minus 1 by 2 into x square and so on. Now as per our condition, coefficient of x is 3. Therefore, m minus n is 3. And coefficient of x square is equal to minus 6. Coefficient of x square is this. That is this is equal to minus 6. So n square minus n minus 2mn plus m square minus m divided by 2 is equal to minus 6. That is they together is m minus n whole square, this and that, minus m plus n is equal to minus 12. But m minus n is 3. So we get 9 minus m plus n is equal to minus 12. So we have m plus n is equal to 20. M plus n is equal to 21. Now we have m minus n is 3 and m plus n is 21. We have to find m. So m minus n is equal to 3. So 2m is equal to 24. Hence m is equal to 12. So option C is correct. Next, problem number 16 now. Problem number 16. The coefficient of x to the power 4 in x by 2 minus 3 by x square to the power 10. To find coefficient of x to the power 4 in that expansion. Options: 206 by 405, 405 by 206, now 259, 405 by 256, and last option is 405 by 263. To find coefficient of x to the power 4 in that expansion. Option is this. So by calculation, you see first term of that expansion will contain x to the power 10. In subsequent terms, power of x will be decreased by 1 plus 2, that is 3. So next term will contain x to the power 7. Next term will contain x to the power 4. So x to the power 4 is in third term. So coefficient of x to the power 4 is equal to third term, that is 10c2 into 1 by 2. I am counting coefficient. So half to the power 8 into minus 3 to the power 2 is equal to 10c2 means 10 into 9 divided by 2, 10c2 into 1 by 2 to the power 8 into 9. So that actually it is equal to 5 into 9 into 9, 81 into 5. So that it is equal to 81 into 5 means 5405 by 2 to the power 8, 256. So 405 by 256. Next, problem number 17. The problem is the sum r is equal to 0 to m plus r c r is equal to options m plus n plus 1 c m. Next, m plus n plus 2 c m plus 1 m plus n c m minus 1 and n plus m plus 1 cm. Oh, that is cm plus 1. The series actually is, we have to calculate the sum of that series, and options are that. So actually the series is first in the series, first term can be obtained by putting r is equal to 0. So first term is nc0. Second term n plus, second term can be obtained by putting r is equal to 1. So n plus 1 c1 plus n plus 2 c2 and up to n plus m cm. We have to calculate these things. Now we know that number one, NCR plus NCR plus 1. This is equal to N plus 1 CR plus 1. That is here N equal, and these two suffixes are consecutive integers. Then their sum is, this is increased by 1 and this one is higher between this and that. Now here you see NC0, its value is 1. Similarly, N plus 1 C0, that is also 1. So this can be written as N plus 1 C0 plus N plus 1 C1 plus N plus 2 C2 and so on. Now add them. Using that formula, it is equal to, these two are same and these two are consecutive integers. So this is equal to n plus 2 c1. Next term is this, n plus 2 c2. Next term is n plus 3 probably c3. Now they together when added using that formula, it is n plus 3 c2 plus n plus 3 c3. When they added, its result is n plus 4 c3. When this term is added, answer is n plus 4, one more than that, and this one. Similarly, when this will be added by same argument, term will be n plus 1 by c m. So answer is that. Okay, next problem. Problem number 18. And the problem is the coefficient of x to the power 10 in 1 plus x to the power 1 plus 1 plus x to the power 2 plus 1 plus x to the power 3 up to 1 plus x to the power 20. We have to calculate x power coefficient x to the power 10. This will not contain x to the power 10. This is also because its highest power is x to the power 3. But in the term when it is 1 plus x to the power 10, it will contain x to the power 10. Similarly, for all other subsequent terms will contain x to the power 10. So separately, this calculation is very cumbersome. For that purpose, let us add these. Let us add these things. This is actually equal to. This is a geometric series. First term is 1. Common ratio is 1 plus x. So it is actually 1 plus x to the power 21 minus 1 divided by 1 plus x r minus 1. So it is equal to 1 by x into 1 plus x to the power 21 minus 1. So when you calculate this 1 plus x to the power 21 by x, it will contain x to the power 10. But this will not contain x to the power 10. So coefficient of x to the power 10 is actually coefficient of x to the power 11 in that term. X to the power 11 by x, so x to the power 10. So required coefficient is 21c. I actually want coefficient of x to the power 11 there. So this. So options are not given. Actually, this is answer. And given that options are 21c10, 21c11, 20c11 and 20c10. These are the options. So our option is this. Okay. So today let us stop it here. Next day we will discuss few more problems. Thank you.